So in this video, we're going to look at another exception to the octet rule, and this exception involves elements that are what we call hypervalent. And a substance that is hypervalent, or an atom that is hypervalent, has more than 8 electrons that is involved with bonding or lone pairs around that atom. So it will have more than the octet. So an example of a substance that is hypervalent is PF5. Now you may not realize when you're given the substance that something is hypervalent. It may only be when you're starting to draw the substance itself. And so again, kind of like free radicals, you don't really know by just looking at the formula, but you would later on when you're trying to build it together. So let's look at PF5. We're going to start with our NASA table. So NASA, and we're going to make a column for phosphorus and a column for fluorine. And we have one phosphorus. It wants a 8 because it likes an octet. Our 5 fluorines want 8 electrons because it also follows the octet rule. And this sums up to 48 electrons. Our one phosphorus has 5 valence electrons available, and each of our fluorines have 7 valence electrons available, and that sums up to 40 electrons. We'll take N and subtract A to get our number of shared electrons, so this will be 48 minus 40, which will give us a value of 8. And then we'll take A minus S, which is 40 minus 8, which will give us a value of 32. And each of these last two values here, remember, we divide by 2. So divide by 2, divide by 2. This gives us 4 bonding pairs and 16 lone pairs. And what we're going to do now is, see, nothing looks amiss. Everything kind of looks like we've gotten everything worked out on the NASA table side. And now where we start to see some issues is when we're building the structure. And again, we're going to try to keep members. If we have a center atom, let's put that center atom down first, and then we're going to try to attach everything to that center atom. And so we have phosphorus is the one, and it turns out we have 5 fluorines we need to add. We're not going to be adding things in a way that we can put things in a perfect north, south, east, west quadrant. So I'm just going to try to make this thing look symmetric in all of my fluorines with one bonding pair attached to our phosphorus atom. And what you're going to do now is, okay, so now we have phosphorus attached to each one of the fluorines, and now we're going to try to match up our numbers. We'll see in our NASA table, it says we were supposed to have 4 bonding pairs. But if you go and look at our structure, there's 1, 2, 3, 4, 5 bonding pairs. And remember, we have to match the structure with what the NASA table says. Well, the structure can't change. You can't get rid of a fluorine. You can't do anything. It doesn't matter even if you start to move fluorines around or whatever. You're still going to have 5 bonding pairs. So this means we're going to have to change the NASA table 4 to match what we see in this structure. So that means that 4 is going to have to become a 5. But it just can't magically appear from anywhere. So what we're going to do is it needs electrons to make that extra 5th bonding pair. And we have a stockpile of them in our lone pair group. So what we're going to do is we're going to remove a pair from the lone pair, and we're going to make it a bonding pair. So did everybody see what we did? We removed a lone pair, so now we have 15 left over, and we bumped it up to become a bonding pair. This is a one-way street. You can only take a lone pair and become a bonding pair. You cannot go the other way. You cannot take a bonding pair and make that a lone pair. Not in this NASA table. Okay? So it's a one-way street. So now our bonding pair does match. Let's now look at the lone pair. 15. Let's go put our electrons around our structure. So remember, what do we do first with our lone pairs? We start with the center atom. And let's count how many electrons it has. It has 2, 4, 6, 8, 10. Notice that this is now more than 8. That means phosphorus in this structure is hypervalent. And that's okay. If it has more than 8, well then we definitely don't need to add any more. So we just go to the rest of the atoms and start to fill their octets. And it turns out each one of the fluorines needs 6 more electrons or 3 lone pairs, and that'll total up to 15 lone pairs. And we will have finished our Lewis dot structure of PF5. And that is it. So we check that off. So this is one of the second exceptions to the octet rule.